Good morning. The intent of today's video is to discuss one of the benefits of the concept that we call MODSIM, integrated modeling and simulation. In any organization, designs go through revisions. Revisions get revised, revision A, revision B, revision C, etc. First, we are going to see what is MODSIM quickly, and then we are going to see how to reduce work in setting up simulations for these newer revisions as these newer revisions come up. And as I'm going through, I'm going to elaborate on a few options that exist and how to leverage them in order to reduce the amount of work in setting up simulation or any downstream process for a design on 3D experience. Here, what I have on my screen is a disk break. I have it on Explorer mode. I also have it open here. It has been meshed. You can see the logo disk A over here. I have meshed it using some quality rules. So the intent is not to show you how to set up a simulation or how to exactly change the design into design B, etc. But I am going to start with design A. Design A already has a simulation attached to it called as simulation A.1. You can see the revision numbers here, A.1 associated with design A.1. And the main question is, what if design B.1 comes in? How do I quickly revise all the simulations for design B.1 without having to start from scratch? So before we go into details, this has certain clauses that I want to say ahead. Number one, this is the most simple version of the process that I'm going to demonstrate today. This is only applicable, number one, at a part level. So this is a part, okay? We don't have a subassembly with a bunch of parts. That process will be somewhat different. Number two, it also assumes that the designer and the person doing the analysis is somewhat the same. If they are different, then we have additional pieces that puts in guards and rails so that everybody is aware of the revision and replacement and not just in one click start changing things that you don't want to change. So this is a very customizable process, but my intent is to show you the very first basic building block to demonstrate how to reduce rework in an environment that has not been configured too much. If there are additional configurations in your organization, then you may need to discuss with your PLM admin on why this is not working, why are you seeing certain behavior that is different, etc. So with all that, what I'm going to do is that number one, we have this design disk break A, and I've set up a simulation A on top of it. What I'm going to do is that I am going to go into Explore mode. I have my collaborative lifecycle open. I am going to create a new revision and I'm going to select this. Okay, so you will see this become light blue and it will revise both the part and the finite element model simultaneously. Basically, given this product structure at a part level, both of these objects will get revised simultaneously. Great. Now we see that this revision was successful and that B.1 has been created. If we expand the tree, we should be able to see, the 3D shape is now B.1. This is also on B.1. So I'm going to quickly open this and make a very quick design change. I'm going to change it from disk A to disk B so that it becomes a little more visual. Now that it is open, I'm going to select the logo here, and then I'm going to select the sketch. I'm quickly going to change A to B so that we have a visual representation of this disk B. I'm going to save the changes. What I'm going to do next is that I'm going to search and open this simulation A1 in Explore mode so that I can create a revision for that simulation. I'm going to revise it to B.1 so that I can have a new simulation for the design that we just created in B.1. So I'm going to explore. You can see its collaborative lifecycle. I'm going to expand it a little bit. Now I'm going to create a new revision for this simulation. It'll tell you which objects it is going to revise. Okay, I'm going to click on OK. Now we have B.1 version for simulation, and I'm going to open that particular version of the simulation. Now we have it opened in a new tab, and as you can see, the simulation version is now B.1, but we have not told the simulation to refer to the B.1 revision yet. It still thinks, hey, my model is still A.1. It does not automatically start revising your designs. That will be a very bad best practice. It knew only to preserve your revision, make a revision for your simulation, but it is still associated with the A.1 design. So now you have two different objects. We have design A.1, design B.1, and also two different objects for your simulation, simulation A.1 and simulation B.1. So now all you have to do is right click, go ahead and say replace model by a branch or revision. But before I'm going to do that, I'm going to quickly explain what are these other two options. Ideally, you should be able to just choose a very different model or replace with any model so that you don't have to revise that design. You can just keep replacing one design with any other design. But I want to highlight that these two options, they don't exist for simulations in the physical world. They exist for simulations about those are somewhat in the logical world where they're not associated with the physical product. Logical simulations, kinematic simulations, they don't work based on a physical model. They have their own product structure. So these two options exist for different type of simulations, but not exactly for physical simulations like FEA and CFD that we are setting up. If you would like to replace one model with any other model, we do have the mechanism. It's called simulation templates, but we are going to reduce our focus. We are just going to see how to replace one branch or revision with a different revision. And that's all we are going to focus about. So here we can now see, I'm able to see the different designs. This is still, I'm able to see the history of versions. Okay, this is disk B. I want to highlight that as long as you set up the preliminary requirement is that you use publications to set up your loading and boundary conditions, and those publications are referred in your scenario. As long as those connections are intact, this should work like magic. So I just selected B.1 here, and there we go. Disk A.1 has been replaced by disk B.1. We can see disk B. There was no other additional steps involved. Everything is intact. All you have to go and do is update your simulation. And you can see that everything will automatically get updated. There was no remeshing. There was no resetup of your scenario or physics. This way you can reduce a lot of rework and reduce your design time cycles. You can see that the checks are completed. Once again, this only applies when designers are doing simulation. We only discussed up at a part level. This is possible to be scaled up to sub-assemblies and assemblies, and we can introduce as many customizations as required. But this is just a baseline for you to understand how MODSIM is supposed to work at a part level when the design and simulation are being done by the design person. I hope you enjoyed the video.